So for today, it is cosecant and secant. So I'm sure this entire time that we've been graphing sine, you've been thinking to yourself, I wonder what secant looks like. Well, I'm about to tell you. So let's get started with just a little bit of review of sine and cosine. Because if you can't graph those, you can't graph secant and cosecant. So here's a typical normal sine graph. Would you please graph y equals sine of x, including all the x and the y-axis labels. This should be like the back of your hand. And then under that, make another graph for cosine. I'll pause for a minute while you get those two. Label all the x-axis and the y-axis spots. That's super important. So you might just think that I'm reviewing with you, and I am, but you can't draw cosecant without sine. So I had to have you start with sine. So here's what I hope your graph kind of looks like. Now, you could go higher on your peaks or lower on your peaks than that. You know, maybe you were more like this. Okay, awesome. But wherever you decided 1 and -1 was, this is where 2 pi had to be, and this is where pi had to be, and this is where half of that is, pi over 2. And then I taught you to go 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2 in case we wanted to do some kind of a stretch or shrink on the x-axis. Now, if at this moment I put a 5 here, just tell me what I would do. Yes, sir?
Multiply the denominators by 5.
Yep. Another way to say it is divide everything by 5 or multiply the denominators by 5. So this would all of a sudden become 1 pi over 10, and that's all you really need to know is the first one. Because if that's 1 pi over 10, then this is 2 pi over 10, 3 pi over 10, 4 pi over 10. Okay, that's just a quick review. Now, on top of our sine graph, I'm going to erase the fact that we have sine. We are going to graph the sister function. So what do you think? Which one goes with sine? Cosecant. CSC of x. Okay, now go back to what you know about cosecant. Would you agree cosecant is 1 over the sine graph? So we really want to do y equals, we really want to graph 1 over sine. Well, we already graphed sine. So each of these spots, we want to do 1 over that. Would you agree that that spot right there, if I do 1 over it, then that's going to take 1 over 1, because its height right now is 1, and these are y values. Remember, it says y equals. So the y value there is 1. And if I put 1 over 1, it'll stay the same. So that and this spot are the only two spots, 1 and -1, where cosecant is right on top of sine. Because at that exact spot, the y values, which is what we're doing, 1 over the y values, you know, it says y equals. So we're doing 1 over the y values. At those spots, it'll stay the same. How about at these spots? I'm going to make them blue. Right here and here and here. What's going to be special about those spots? Well, what's the y value on those in the first place? 0. And so what happens when I put 1 over 0? It doesn't exist. So then put asymptotes there. Because 1 over sine won't exist when sine is 0. Okay. Now, your graph ends up going in right there. I can explain why. When you put 1 over something, what if that something is really big, like 1,000? What's 1 over something really big?
Something really small.
Really, really small. What if you have something really, really small, like like this spot right here? Do you get it's way lower than 1? It might be like 1/10. if I have 1/10 and I put 1 over it, do you get that that flips it over and all of a sudden it's 10? Okay, so as this one gets really, really small, this one gets really, really big. That's why it goes up like that. All right, how about this spot right here? Well, it's really, really small. It's negative, really, really small, like it's negative 1/10. And then when I put 1 over that, it's like 10. So it's like way, way, way down there. So same deal. Can you cross asymptotes? No, except for sometimes you can cross horizontal asymptotes, only in certain weird situations. You may recall that from before, but we never crossed vertical asymptotes, so we still don't. Okay, so that graph, that's cosecant. Now, all of this other stuff, because it's like showing your work, I'll allow you to leave it there. But really, it's not part of cosecant. Cosecant doesn't have that. It's just these loops. And it needs to have an upward loop and a downward loop to complete one complete cycle, so it still is a 2 pi period. Stayed up too late last night. Okay, that's what I'm saying. Stayed up too late last night. All right, so this is cosecant. What do you think is going to happen for secant? Same exact thing, except it's going to ride on the back of its sister function, which is cosine. So, if you haven't already, I told you to make cosine. Cosine's a valley. And then important spots, 2 pi, pi, pi over 2, 3 pi over 2. That's 1, that's negative 1. And if this was cosine, I'm actually going to graph secant on top of it. I'm going to write that off to the side because secant goes above it, so there's not going to really be room. So I'm going to over here, I'm going to y equals secant. So you draw cosine to start with, and then I want you to guess, because I think from what I just showed you, you can predict what this is going to look like. Because secant is 1 over a cosine, just like the other kind. You shouldn't need me to tell you. Stretch that cerebellum. Work those synapses. Huxton, tell me something you think you know.
The ones are the same on the cosine and secant.
And?
The negative one.
Yup. Those are all the same. Cool. Got that. What else?
The zeros, so on pi over 2 and 3 pi over
It's like there and there. What happens?
those are asymptotes.
Yup. Ashana, can you finish it? The loops. I call them loops too. Like that. And this is kind of weird because it doesn't extend over. And the reason I'm stopping right there is that's how you get one complete period of secant. Now, does it continue? Well, yeah, if you wanted more than one period, it would continue. Marcus, go get a drink. It'll help. No. Take a walk to the drinking fountain. Get a drink. Yes?
Just like, is one full period always 2 pi?
Yes. Only time it's not 2 pi is if you have stretched the thing. So like if I change this to a 4 right there, now it won't be 2 pi anymore. But otherwise, always start with a period of 2 pi. Tangent is one that starts with a period of pi. I want to remind you at this moment, because sine and cosine, and secant and cosecant all have a 2 pi period, that's most of the functions. But tangent and cotangent have a period of pi. All right, so back to this. So if I wanted to continue the graph, A lot of kids do this and they're like, oh, this needs loops. I want to finish the loops. Okay, fine. Now you just did way more than one period of the graph. And they're picky on that on the test. They'll say graph 1 period of or graph 2 periods of. And this isn't even 2 periods. This is like 1.5 periods of it. Because to get 2 periods, you'd have to have another lower loop. So if I needed 2 periods of it, I'd need to continue this graph to what it would do. And that's what it would normally do, right? And then I would need 2 ups and 2 downs. Because 1 up and 1 down was enough to get me a 1 period. So this could be, let's see, I have 2 ups and 2 downs. There, yay. Now that's 2 full periods of secant. I feel like that's wrong, but I'm double checking myself. 2 ups and 2 downs. No, that would be correct. All right, but I technically don't need this in here anymore because it's just riding on the back of its sister function. And one more asymptote I should put in there. There, it wouldn't hurt to have asymptote there and there. And then if I had to graph 2 periods of it, I'd need to label all these spots. So I was good so far, but now all of a sudden you got to label this spot and this spot and this spot. And I've been trying to teach you this 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So this becomes 5 pi over 2, no problem. And this is 6 pi over 2, no problem. And this is 7 pi over 2, no problem. That's why I teach you to number it by ones like that. So if this was 1 pi over 2, then this here is 0. And then over here is negative 1 pi over 2. And I could keep going if I wanted to. The next mark would have been negative 2 pi over 2, etc. Okay, so there's a quick overview of how to do secant, which is riding on the back of its sister function cosine. All right, so now let's look through. It asks you to graph cosine and then do a stretch and a shift of cosine. This is a good practice, except we've already graphed cosine, so let's skip that part. Let's do this, though. And I'm a little afraid that some people are going to get screwed up on the inside because they aren't going to factor it out. So I'm just going to say it. Don't forget to factor this part right here, because if you can factor it, you should. The 4 comes out. See if you can figure out what it should look like then. And try to graph this. This is a typical R3, harder question on the test. I almost think we should be testing you on Thursday, but we're not, so. We do have one more thing to teach you, which is tangent. And then we need a review day, which will be Thursday. So since you guys aren't here on Friday, we pretty much can't teach you that. So we're going to teach you some a little more advanced stuff, like how to write equations for using data, like real world data. So we'll add that to it. We'll do that when you come back. So bottom line, you're close to being ready to do the graphing part of the test, but there's more to the test than just graphing. Here's regular cosine. So, Mr. Brahma, that part where I asked you to factor this, are you capable of doing that?
I think so. So it's 4 and then x plus, let me just be pi because
All right, so let me ask you this. If I multiply this back out, what's 4 times x?
Oh, that doesn't work.
Ah, you're realizing now it'd be 4 pi. So, So you got to think, what could I put on that pi so that when I'm done multiplying it by 4, I have pi over 4.
Well, what's...
Give you a hint. I better put it over something. So that,
yeah, that's 16.
there it is. Nice. Because now this one multiplied back out would be 4x, and that would be 4 pi over 16, which reduces to pi over 4. Cool. And then I have a minus 1. At the end, you're just going to move the whole thing down 1. I think you all know that. But let's do this part much harder first. That 4. Sam L., how do I stick that 4 into my graph?
Like multiply by the top.
So I'm going to multiply this by 4. Oh, okay, good. Okay, so then this becomes pi over 4 times 2, which is really pi over 8. And then, do we really have to do that everywhere now? So I've got pi over 8. What are you going to do now? So the next one here will be 2 pi over 8. Can you continue it? Keep going. Yep. Now, could we reduce those? Sure, but it'd be kind of dumb. Because what if I need to move this thing over? Then I'd want to know that the next one's 5 pi over 8. So we'll reduce it at the very end when we're all done. Okay, so now, where do I have to move this thing? Let's go with... I have a few people I'd love for you to get your name tags. Anya, Lucas, Audrey... Sammy, where's your name tag? Slide it over, thank you. All right, we're gonna go with Sam W. How do I do this shift to the right, no wait, to the left of pi over 16? Because it's got a plus pi over 16. Nice. He said that this is the length of pi over 8. And so if you want to move pi over 16, that's half of that. So now he knows that we need to move everything over half of what he called a tick. And I agree. That's a tick. Tick, tick, tick. Okay, so half of 1 tick. So that's about 3 boxes are the way I've drawn mine. Now, you could draw yours differently, but... All right, so I'm going to move it over about that far. So everything moves. I'm going to take the 4 key points. There, there, there. Actually, there's 5 key points. Those 5 key points, I'm going to move them all over about a half a tick. Why am I going left? Because it said plus. And when you're on the inside, that's what that means. I should use a different color here. I'm going to use red. There. The red one is shifted to the left. Pi over 16. All right. And then last but not least, Marcus, we have to move it again. Where? Down 1. So what's 1? Is it a full tick on the y-axis? Yes, it is. So we're going to move these down that far. Now I'm just trying to try to keep it the same on all my spots. That's about the same distance. That's about the same distance, about the same distance, about the same distance. And I'm going to make my final graph green. And it should still look like a valley. There we go. Ah, so close. I've burned you 3 times on this. Maybe some of you caught it. Did any of you catch that we need to label this spot right there? The x value of, there's nothing there. Okay? So, we need to label that spot. Well, it's on, it's on the x-axis, so that's clearly 0, but or no, sorry, the x-axis means that y is 0. So how about the x value of it? Well, it's shifted over half of a tick. So that spot right there is not negative 1 pi over 8, because we only went over half of a tick. So it's negative pi over 16. If it was over a full mark, which is this far, which is further, basically, was over there, then we would have said negative pi over 8. Now, gee, this is about as tough as they would ever get. All right, let's go back and answer these questions. What was the amplitude of this thing? Drew Malk, what was the amplitude? 1, good. The period of it. Well, I'm going to write 2 pi over b, because that's the generic thing that it is. But Callie, what is b?
4.
So therefore, what's my period?
Pi over 2.
Yep, 2 pi over 4, aka pi over 2. Sammy, what is the horizontal shift involved here?
Oh, you go to the left. Negative. Or left. Pi over 16.
Pi over 16, that is correct. It's also called the phase shift. And last but not least, Caleb, the vertical shift.
-1.
True.
Or down 1.
I would say down 1, just to be safe. Because we're trying to, like, I don't even know why I would say that you had to say down 1, but I would. This one is directional, though. It's really common for kids to forget to say left or right. This one, I think if you said -1, I'd have a hard time marking that wrong. Down 1 would also have been okay. Okay, cool. So there's a good review. Now, let's see if it's been long enough that you've forgotten how to do secant. Hunter, how am I going to start doing secant?
Put 1 and -1.
True, but first I got to graph something. What do I got to graph first?
Going up.
Okay, so I'm going to graph which function? Cosecant? Sine? Cosine?
Cosine.
Cosine, there we go. So everybody graph cosine. I personally like to do it by making dots, and then I know it looks like a valley. Davis, what's the x-axis label starting from right here? Pi.
Over 2.
Okay, keep going.
2 pi over 2.
Nice.
3 pi over 2.
Yep.
And 4 pi over 2.
Good. And now, if we're really going to graph secant, all we've done is graph cosine so far. Key spots, Davis?
Is it the pi over 2 spot? Is it an asymptote? And then the 3 pi over 2?
Good. Ashana, 3 more key spots. It's at 1 here and here, and it's at -1 there. And then last but not least, you put the loops in, and I'm going to make my graph black. Why am I not completing the loops on the top? Because if I do, I will go more than 2 pi. That is just 1 period right there. It's got 1 full down loop, and it's got 2 half up loops. So then you're equal to a whole. That's 1 complete period of secant. Yes? I would absolutely do it just the way I did it. Now, I just want you to know, I do believe in kids showing their work, and therefore I feel like I can have you leave it in there. And in some years in the past, I have said that you have to erase this out, and then I was like, is it really? That's just them showing their work. So, yes, the graph in the real world does not include that, but it's you showing your work. So I don't feel like I should mark it wrong for a kid who leaves their cosine in there. See what I mean? You could argue that you're just showing your work. So, okay. So what if I had to do 4 secant? Well, let's not redraw this whole graph. Let's just actually incorporate this into our graph. because we really just have to change the labels. Now, it's a regular 4, not a negative 4. If it was a negative 4, everything you have to flip, which would be a pain in the butt. But it's not. So the regular 4 just right here just is incorporated by putting a 4 there and a negative 4. And then if I wanted to get this 3 in there, true or false, I multiply everything across the bottom by 3. False. I multiply everything across the bottom by 1/3. So when I multiply this by 1/3, then I end up with, well, I can start counting it up. Pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6. Cool. All right. So this is nasty in 2 ways. It's got a negative in front, which means at the end, when you're all done, do a vertical flip. So that what that'll look like is, let's say you have a loop here, then the loop just has to go down there. And it's not here anymore. Okay? The asymptotes will stay in the exact same spot. Let's see if you can handle one that is that hard. That is a typical hard cosecant, about as hard as it would get for the test. See if you can do negative a half cosecant pi over pi x. Henry, what are you starting by graphing?
5.
Excellent. Here's the way I'd like to start graphing my sine. Asymptotes come in. This turns into a half, a half. Now, I would do my renumbering next. I guess it wouldn't matter too much. The shifting, there's no shifting, thankfully. So I multiply the bottom by pi. Do you get that every time I put the pi on the bottom, this will cancel this, and then you'll have just a plain 1 or 2 or 3 on top? So 1 half, 2 halves, 3 halves, 4 halves. Now, you could either draw the loops now and then flip the loops, or you could flip the sine over and then draw the loops on top of that. That's what I'm going to choose to do. You could have done it the other way. Your final answer should look something like that. The red loops with the asymptotes where they are. On a scale of 1 to 5, how many of you feel like you're at least at a 4 or a 5 level of understanding this? Okay, good. All right, so got a few problems for practice. Let's just talk this one through for a second. Is the amplitude negative 11? Be careful. What is the amplitude? 11. This one's cosine, so I don't need to do any like graphing of a sister function. And you just start right off with the standard cosine graph. Remember, I don't really like all these marks. I just pick whichever one I feel like. I'm going to call that one 1. I'm going to call that one negative 1. I'm going to draw my cosine on there, making my valley. And I'm going to just try to use up most of the graph. So I'm going to call this very end here, I'm going to call that 2 pi. And so don't be a slave to exactly where all of those hash marks are. So I'm going to say that's the halfway mark about, so I'm going to call it pi. And this is pi over 2, 2 pi over 2, 3 pi over 2. This is where that hits. Okay. So there's regular cosine, and then you can change the numbers from there. Make sure you fill out this part too. All right. So do that one for sure. And this is all we have left. So I do feel like, considering I'm giving you a fair amount of work time today, you should just do all of these problems. And there's more shifting than normal, as you see. They're all shifted in some way. And this one's got that weird factoring thing. And note that at the end, that you got to factor that 2 out. A lot of people shift that pi, and they are wrong. Factor that, because if you can factor it, you should. That's all I got for you for today.